But we will start with Priscila Caçola, talking about motor proficiency. Oh, no, doesn't match.
I just changed a little bit. I promise that we need that. So I'll talk a little bit about using a unique approach. And it's not really unique, but it's just a different approach that most people use to look at accuracy and reach estimation via motor and visual imagery in children. I'm pretty sure this is going to be preaching to the choir, but so we all know that motor development is the key forecaster to the development of certain abilities. So there were several talks earlier about even how motor development actually helps a lot with social interaction in children, and that's a big deal. So it actually possesses a leading role rather than being just a key participant. We know this too, that motor development is age-related but not age-dependent. And Dr. Clark, actually, in the room said that we need to consider developmental progress itself as the means to look at change rather than look at age alone. And when I talk about all this first slide, it looks like it's really old school. We have moved from this idea a long time ago. We all know that age is not the biggest predictor of motor development, but it still seems that we looked at several talks that talked about age differences. And I know that age is just a general characteristic that we look at because it's really easy to explain development based on certain age characteristics. But we need not to forget all the characteristics that are underlying age that are really predicting development or change. I'll talk a little bit about estimation of reach. So estimation of reach is actually essential for navigating the environment. So there are several ways that we can talk about this concept. So perceptual judgments, or getting from an actual state to a desired state. In fact, infants by 8 months of age, they realize that they have to lean forward in order to reach an object. So we develop those abilities very early in life. There are also several distinctions between peri, near space, and extrapersonal or far space. So between 5 to 11 years of age, there is a developmental lag between the development of accuracy and reach estimation in these two spaces. In other words, children, or very young children, they tend to overestimate their reach ability. So they estimate always more that they can reach. On the other side of the lifespan, it's actually the opposite. It appears that older adults tend to underestimate their reach abilities. There are also a couple of concepts that we can talk about when we talk about reach estimation. So we can talk about the concepts of motor imagery and visual imagery. Motor imagery is any simulation that involves the motor component. So in the case of the baby in there, it would be when you reach and you actually scale that, so the distance of the cup based on your reach. Visual imagery is a perceptual simulation, but it does not involve the motor component. Babies show visual imagery abilities, or toddlers by 2-3 years of age. Motor imagery abilities are a little more complex, who actually develop a little bit later, so by about 5 years of age. And I also want to talk a little bit about cognitive styles. So cognitive styles are actually, they relate to an individual's consistencies in using cognitive ability. So we all talk about how I am more this way or that way. So there are actually ways that we can do this. There's one called visual spatial ability, which is related to how you orient yourself in space. And there's also something called visual object ability, which is related to extracting object properties from the environment. So if you're more spatially oriented, you are actually, you think more about landmarks in the space and how you can move around. And if you're more object oriented, you actually focus on objects rather than relationships between objects. I have to say that cognitive styles are related to preferences. So it can be related to your cognitive ability, but also related to how you feel that you estimate your life better in the environment. So my purpose was actually to look at what factors shape accurate reach estimation? So reaching is a very important ability, and we have to be accurate a lot of times to perform that ability. So, and I wanted to know a little bit what was different for motor imagery and visual imagery components. So is there a difference when we estimate reach using a motor component or not? So I looked at age, which most of us do in motor development studies, but I also wanted to look at motor proficiency or motor experiences, cognitive styles because of the way we orient ourselves in space or in relation to an object. And I wanted to look at one analysis, I wanted to find one statistical method of analyzing this that would not rule out all my other characteristics and would only show me age. And I'll tell you a little bit later why. In this type of analysis, I can actually, in the Generalized Linear Mixed Model, there are a couple other names for that. It can be called a multi-level linear model. Some people call it a random linear model as well. I can actually consider age a random coefficient, and all that is that it makes age inherent to each participant. So if you're 7, you're always going to be 7. But the fact that you're 7 years of age will not interfere with how the other parameters actually interact with each other, okay? So it kind of rule out the age effect a little bit. So I looked at 38 volunteers, so ranging between 7 to 13 years of age. There is a reason for that. The tasks that I use are only good for a 7-year-old, and after 12 or 13 years of age, we see a ceiling effect. I used the Children's Object Spatial Imagery Questionnaire. It has 2 scales, and I gave you examples of each scale in there. So what that does is that you can choose how good you are in each one of those skills, and kids can do this on their own. So if you say, for example, when reading a book, I can usually imagine clear, colorful pictures of people and places, and I can rate actually how well I do that, or if I don't do that well at all. And for the spatial scale, would be the same thing. The best way to think about visual spatial ability is a game called Minecraft, that if you have kids or have been around the kids these days, you probably know it. It's a big deal. And it's really how you orient yourself in the space. That's all that game is. So the reach estimation tasks, so there were 2. They used 2 different components, motor imagery and visual imagery. All that is on the motor imagery is you estimate reach based on your own reach, so it's scaled to you, and it looks at estimations in near and far space. And when we have the visual imagery task, it's actually pretty similar, but all that is that you estimate a distance of an object in relation to another object. So it's not scaled to you, it's scaled to another object. So you have to say where the red target is in relation to where the blue target is, okay? Everybody did all the tasks, and the order was counterbalanced. I also did a motor assessment, and I looked at the bot. It's a comprehensive motor assessment. The reason why I chose it, it's one of the few assessments that we can use that has a very large age range, so between 4 to 20 years of age. It has 53 items in 4 categories, so fine manual control, manual coordination, body coordination, and strength and agility. And it's also product-based, so a lot of times the form of the items are not as important as completing the items. So I use the GLMM. It's a weighted model data that actually clusters participants into age level. So those are the random coefficients. Okay. And the dependent variable is binary, so the success or not, whether they estimated correctly or not. One of the ways that we can think about this is you consider age as a baseline category. You cannot dissociate yourself from your age, even though some people try to do this. That's the age you have, but we want to explore the other factors that are within your age. And that enables unique relationships to emerge. So let me show you the results. They kind of, maybe you can't see it really well because we have to go through the intercepts for the fixed effects, which are all the other predictors, and the random effects. But I want to point out, I want to actually highlight two interesting things that happen in here. So we have motor imagery and visual imagery. And so motor proficiency and the object and visual and spatial skills are actually fixed effects. And then we have age in here. So the only significant intercept is the one for 7-year-olds. There is no other time when actually age predicts accuracy in reach estimation. And if we look at all the past studies, we will look at age differences, okay? So this is really interesting that it's only at age 7. We'll talk about age 7 a little later. And then when we look at motor proficiency, we actually see that it predicts accuracy, and it's not, the variance is not very high, but it does predict accuracy in both motor imagery and visual imagery tasks, or estimation of reach tests via each one of those components. The object scale also predicted accuracy in the estimation of reach tests via motor imagery. Now, it's a little more interesting to talk about why those things happen. And it's interesting to think about 7-year-olds. When we say age-related, that motor development is age-related but not age-dependent, actually by age 7, we see huge changes in the child. And of course, we know that it's not the birthday that is triggering those changes, but there are a lot of social and cultural changes that are happening with that birthday. So it is the only significant intercept, and when we look at 7-year-olds, we can actually look at age-dependent differences. Now, there is a relationship between visual motor ability and cognition that is established at age 6, so we actually see maturational triggers in there. Also, we saw that the object scale predicted accuracy when kids estimated reach from a motor imagery perspective, so with the motor component. And what I believe that this is happening because whenever you use more cognitive styles that are related to the object and not the space, you are estimating distances or even scaling distances based on the object and yourself. So that may increase your ability to estimate distances from your perspective, which doesn't happen with the spatial scales. In motor proficiency, so when we talk about motor proficiency or motor development or motor ability, so we use a lot of different terms to talk about actually all these experiences that we gather. They're very related to age, but that make a huge difference in the child's life. So I think most of us believe that, but it appears that motor proficiency can shape how children represent, plan, and act on environment, and we know that already. Now, more interestingly, that it's if I did this study and I didn't show the results, if I were using a simple parametric analysis, all that I would see is that age predicts accuracy. That's all. I wouldn't see any motor proficiency effects. Now, by ruling out age, I actually saw motor proficiency emerging, and that's pretty cool. So age tends to obscure the fact of any other characteristics. And I think when we talk about the real motor activity of children, all of the things that involve in the simulation or the cognitive simulation of an activity is also dependent on a child's real motor proficiency. So there is a lot in there that is dependent upon how we move, the experiences that we have, and our status at a certain period of time. It also, if you look at the literature in motor imagery and motor activity, a lot of people say there's a relationship between motor imagery and motor skills, and that gets stronger with age. There is a debate on that, and I think that after looking at other statistical techniques that can rule out age effects, it appears that actually this relation gets stronger because of kids' motor experiences and not age. And there are a couple of considerations in there. And so, like I said, this actually seems to be really old school, like we moved away from the age situation a long time ago, but we still see a lot of age-related differences, which is okay, but when we look at age, we need to be very careful to explain what is it in age that is actually causing changes in accuracy in whatever task you're looking at. The model that I chose, and it's really not very difficult to conduct, allows other factors to emerge instead of being covered by age effects. You can still use age, which is really cool, and we should. The motor development is age-related. It is a potential predictor, but it doesn't limit the analysis, and that's important. So I think I said this many times, but you know, about age outdoing variance in many other factors. But I want to conclude by saying that using the appropriate type of analysis can help determine more specific contribution of motor proficiency in distance estimation accuracy. There are several new studies that are looking at how people who play golf or soccer, for example, can have better object and spatial abilities and can estimate things in the environment much better than people who don't. So that's not a relationship between motor proficiency and distance estimation abilities. It does provide this unique perspective on developmental factors. And I also want to say that this is not a new idea at all. And I've seen two studies recently that actually provided other models, and they're very similar, by the way. One of the studies was done by Bradley King and the other one was Melissa Pajulinan, and in fact, the titles of these studies look at, you know, statistically characterizing, you know, factors that predict something, or beyond age and gender. And this is interesting because both of those studies, and you can see that they're very recent, what they are highlighting is that we need models. And we don't even need to create the models, they are there, but we need to use the models that allow deeper relationships to emerge instead of just focusing on their changes between a 7, a 9, and an 11-year-old. And with that, I would like to thank you, and have any questions?
Time for one question.
So when you say that by age 7, the relationship between cognitive and motor ability develops, are you saying that that motor ability predicts cognitive ability in adults? That is, we've heard for years that the stereotype of the dumb jock is wrong because, in fact, you know, people with higher IQs are actually have better average motor skills. Is that true? And is that what you mean by, at a certain age, the relationship between cognitive ability and motor skills is established?
Okay, so I think I'm going to answer with that. I don't think that's true anymore. We have so there are a couple of new studies that are looking at the relationship between cognition and more, I think, motor ability in the sense of physical fitness. And we see that there's a lot of relationships right there. I think even in children, there's been several studies looking at how actually children that have motor experience and are highly motor competent, they also have higher cognitive ability. So there seems, well, of course, it's not a direct relationship, but we've seen some underlying relationships in there. When I say that by age 7, the relationship is in there, what I'm actually trying to say, and I may not have explained that well, is that the age, even though we tend to move away from age as a maturational trigger for any sort of performance when it comes to motor skills, age 7 is strong enough intercept to actually predict change. Okay? So change is age related, but by age 7 we can actually predict a lot of changes just based on the age. Of course, that is a little bit masked because it's motor experience, it's cognitive experience, it's exploration, it's culture, it's a lot of other things.
but it turns out that it's the only intercept that stays. Now, if I tell you that, well, by 12 years of age, you're going to be able to perform this complex motor skill, in that sense, it's not true. It's not the age. It's actually your motor proficiency that is allowing that.
I'd just like to make a comment about age 7. I think, at least in this culture, age 7 is about the same time that children have accomplished reading, and a lot of mathematical concepts are starting to be introduced. So again, like a developmentalist in infancy, I think it would be a little bit more sensitive to what you're really picking up on at age 7, is to look at something like their reading skills or their other school skills. There's a wonderful study that was done a long time ago in Germany, looking at children who, because of the time that they entered school, there was a nice cohort where you had an age fix, but some children had learned to read and some who hadn't. And they saw a huge difference in memory. So I think that when we pick up on 7, which I agree is a magical age, really, but it's, you know, there's a lot of variability around 7 also. So when you look at something like an intercept, you know, variability is going to play a big part there. So I think being more sensitive to what 7 means would be more helpful.
Thank you very much.